Okay. Okay, so last time in this series, we started playing around with Raylib's image procedures slash functions. In particular, we we didn't do too much. It was mainly just calling a small number of functions. But we're going to use that knowledge to now kind of do what we wanted initially. Okay. So in particular, we defined a really small texture consisting of like a couple of pixels, made one of them like yellow, then scaled it up here. And so where did we do this? We created in this global section. Was it like test I? Yeah, this one here. We made this one here, and then we set it down the bottom here. We created this kind of image, just made a single part of it yellow, and then put it to the screen. Okay, so now what we want to do is to take in the pixels of the bitmap that we loaded from our custom QII parser, and now create textures containing the numerals 1, 2, 3, 4, and then start calling those textures when we're drawing these rectangles in the background. And then this way we'll actually be able to display basically text in like a bitmap, in like a pure bitmap style. Because yeah, in the last app when we tried using Raylib's default font viewing stuff, there were some weird pixelation effects, and just using a bitmap font the pixelation will be there, but it's now part of the art style and not a kind of bug. Okay. So, in order to do this, we need to know some information about the width and height of everything within this bitmap image. And so, let me actually copy. Have one of these running while we do other stuff. Okay, so what was it? It was like Zig image viewer. We moved some stuff around last time. We went to the bitmap stuff. Zig image viewer. 855. Okay. So yeah, so this is our really simple QOI bitmap file that our program is now reading, decoding, and then currently drawing each of the pixels as some square. We want to import each of these as a separate texture. Each of these should have like a similar width and a similar height, but in some cases, in general, the width of these will not always be fixed. When we exported this bitmap from the bitmap generator program, which was this one here, it produced this glyph offset file. I haven't really looked at these in any detail whatsoever, so we can do this now, but this really should tell us the actual width and height of everything in here, which we'll then use. Let's make this slightly bigger. Okay, info face. Oh, this doesn't look like what we wanted. Why is this saying the face's connection to? I thought this was something quite different. Like, it's simple enough that we could actually just count these, but I'm I'm a bit concerned this is saying connection to. We can try exporting this stuff again. Save configuration as. What if I now do bitmap 1 test? We are saving this file descriptor as the text. So no, that isn't what we want. I'm expecting some kind of .txt file with the descriptor stuff, but we don't seem to be getting that. What am I missing? It shouldn't be in here. It should just be, like, I'm assuming when it says this file format font descriptor, this is the thing that's actually going to output something like this that actually has just the offsets for each of these things. But no. This is unexpected. Because this file here is quite different. And yeah, this seems just to have the configuration settings for the program, not the actual output info. Maybe there is an export option that will enable this, and I just have not selected it yet. Could it be in here? No. I'm struggling to see which it would be though. What if we tried, say, like an XML format and exported that? Let's call this bitmap 2 test. What does that give us now? Okay, this is actually giving us advanced info. That's useful. What is it? VT is what we want. Could it be that you need to run this once in order for the stuff to be generated? Okay, seems to be working now. Weird. Really weird. But But this is good. We actually identified that the older file we had was incorrect. So now let's move that in. So we want to actually move now this bitmap 3 test.font to bitmap stuff, and we want to replace it with these glyph offsets, bitmap glyph offsets, and let's still make it this fnt file. Okay. Okay, yeah, this is the one we want. Let's just clear out everything that's changed then. So we want to add everything in. We really don't want to do that. Git restore staged everything. We want to add everything in bitmap stuff. No. Git add bitmap stuff. Okay. Okay, replaced incorrect bitmap offsets. And now let's delete everything that we don't need. Yep. Okay, that's gone. Okay, that was an entire tangent, but now we're back to where we started. Except that I don't want this character ID one here. Why is this here? Did I accidentally click on something? I think I did. I accidentally clicked on smiley face. Let's do this again. We want to just replace it with this. Yes. Okay. Now it's actually correct. Okay. Okay, so we can see from this that the x offsets are all multiples of 10. Great. So these truly are a fixed width. Really easy to deal with. Likewise, all of their heights are the same as well. So all of their y offsets are great. Okay. So now let's, using this, create some images, some Rayleigh images just for each of these individual glyphs. So if we go to main.zig, we'll do that here. We should really be keeping track of these offsets somehow though. I think it would be okay to specify them manually this time, but we will probably want to change this in the future. So magic constant alert. The each character in the bitmap has a x offset that's a multiple of 10. That is a multiple of 10. Each has the same height of 20. Okay. Is the height of this really 20? We can actually check this by just checking out the... I mean, now that I've written the decoder, we know where to look for it in the binary, right? Okay, so the width here is some large, well, like 40 is 44, and then the height here is 20. Okay. Remember, this is 14 in hex, which is 20. Okay. This truly do have height 20. So, how are we going to do this? We want to say, we want to generate 4 textures. And we're going to want to make these globals. So instead of this one here, it might actually just be worth having an array holding these. So why don't we call these numeral textures, and we'll make this constant array of these, and then down here we'll want to set them up. So we'll really like initialize numeral the textures for 1, 2, 3, 1, 2, 3, and 4. We can just say for 0 going to 4, I captured this as I. The numeral textures I is equal to rl.load texture from image. Then the name of the image, which we'll also need to set up. Why don't we do these up here? Similarly, we could say numeral images is going to be something of type rl.image, and 4 of these. We want to load these, but do that for the moment. And let's set these up. So now we want to say, likewise for 0 going, for numbers for 0, 1, 2, and 3, simply make this equal to gen, and remember gen image, not get image color, as we learned last time. Gen image color, the width and height of everything. So if this already has a height of 20, let's just make everything square. So I think it will be easier this way. Okay. So now here is an important choice. Should we give these a background color now? I'm tempted to instead make these transparent. But maybe this is like there's a couple of options. We can either make this transparent, and when we actually start filling in the pixels in these images, kind of write out everything and what everything would be, or we set some of them now and then we selectively write out some of them. I feel like the option that gives us the best flexibility is actually making these transparent. But we're going to have to set up a color for that. make transparent. Ooh, our usual function here won't work. That is okay. We can just copy what it's doing. So let's just make everything 0. Surely there's a nicer way of initializing this. Will the compiler yell at us if we do this? We'll see. Okay, so do all of that just as transparent to begin with. Then now we want to read in the different stuff. But actually, before we do that, let's just check if this compiles. Comment out this stuff, and then actually, okay, we will use transparent. While I'm just checking for compilation, let's just continue to use debug. Okay. Hopefully you're really done with that. And yeah, so do it then. Okay, what is failing? 73. Oh, this is just a copy pasta mistake. Unused capture. Yes, because I want to be assigning to the eyes that. 189. We don't want this test one anymore. We still want to be drawing it somewhere there. And I guess this must be the place where it's getting drawn. Yeah. So why don't here we now say like numeral texture let's draw all of these. But we'll draw them at different places. I'm gonna have to do conversion stuff. Okay. Let's just convert the float from we'll say I is equal to I once it is being converted from an int to this float, and then we'll just draw it at multiples of 200. So this should just give us a bunch of purple squares for the moment, once it's working. Going along a diagonal. Oh, should I say numeral textures instead? And I should be using II here. Wasn't expecting this error. what is it expecting? It's inspecting something of type struct image, and instead it's found struct image texture. Oh, wait, what? If we check out the draw texture procedure we copied and then modified last time, what is this wanting? It's just wanting, yeah, I pointed to a 2D texture. Is this not how we defined this? Yeah, this looks like it's an array of 2D textures to me. Oh no, something's going wrong. Why are we like setting these textures to be the same? Okay, this should be numeral images, for one. Okay, great, and this kind of looks like this diagonal of textures. We're probably just drawing them too big at the moment. That's fine, we can modify them slightly. Yeah, like let's now make them 50 by 50, for example. What? Oh, we're drawing them. No. Yeah, what's happening? Because this is like the center in which we're drawing it, and this is the height. So maybe we'll modify the height as well. Oh, maybe I am drawing them too close together. Like 50 instead. Okay, yeah, that was what I wanted. Okay, we've now it is working as I thought. Here's our diagonals of these textures. Okay. Let's save it a bit before we do anything further. Yeah, lots has changed. So we want to do add everything in bitmap stuff. I kind of don't want this though. So we want to add the glyph offsets. We'll remove stuff separately that we don't need. Git restore staged bitmap stuff, bitmap glyphs. Okay. Yeah, this is what we want. Yeah, started making separate images for the numerals. Okay. Okay, that's now on the cloud. Okay, back to this stuff. Okay, so now let us actually make these transparent. And now do this stuff. We want to transfer the information in our pixels, in the bitmap pixels. I think for the moment we could ignore this. We may as well clean this up. We don't actually need this. Okay. So last time, although we did try these image draw rectangles, given that things scaled really nicely, I think we can actually just copy over, we can just specify the pixels directly. So how should we do this? There's a bit of a calculation we need to do as well. We can do this manually, but given that each of these images has a width of 20, whereas our actual offsets only have a width of 10, we just need to center these slightly. So that is, we want to bump each of them by 5 pixels. Since the images have a width of 20, but the numerals have a width of 10, we want to offset when copying over the pixels. When copying over the pixels from the bitmaps, we want to add 5 to each of the, we want to do a plus equals 5. If I just say that, it's kind of clear what's happening. Okay, so yeah, so now we want to say, what's the best way to traverse the original bitmap pixels? Probably just from going from left to right in some individual rectangle blocks. Okay, so these have a width of 10. And they have a height of 20. And we want to use this, where's our Raylib cheat sheet? What was it? It's like, is it like image set pixel? This isn't the way we do it. We do it by checking the source code. Yeah, get pixel. Let's ignore the case. Get image pixel. Get set pixel. I think yes, set pixel color is I think what we want. Set pixel color, yeah. I take that back. This isn't what we want. I'm not seeing any image stuff here. We saw something that sets individual pixels last stream. What was that? Is it this one? Image draw pixel. I think this is the one that had like all of the complicated cases depending on the image, how the image was stored. But I think this is what it is. Yeah, just a pointer to the image, the position, and then literally the color. Okay. Image draw pixel. Rated.this, and we're going to have to put this inside another for loop as well. This is the numeral index. Okay. So the image we want is now this numeral index. The x position we want is now xi plus 5 times, we're going to have to convert stuff. If we didn't have to worry about converting types, it would simply be 5 times this numeral offset, and then the yi would remain the same. And then the color would be the color of the pixel in the original, in this bitmap pixel. Bitmap pixels. And now for this, it would just be the yi times the bitmap height plus the xi. Okay. Given that this is a type of pixel, I expect that the raylib is going to whinge. So we'll probably need to convert this. Let's just see. Z build one. Yeah. But strangely enough, it's whinging at this. Did I... Oh, it's a pointer. Oops. And then it is whinging that we haven't converted this. Let's do that. I just call it xpos is equal to, so what is xi? Xi is of type usize. This is where everything in here is usize, and so it's complaining because we need to convert this to a integer for raylib. Is this the error? Yeah, it found something of usize, but it wants cint. So why don't we just say, therefore this is of type cint. And actually with that I can just get rid of what I was about to do. Oh no, it's still not liking this. Is usize of type 6, does usize have 54 bits? I felt like it was even variable. Oh, pointer size integer, so it is going to be 64. Okay. Okay, in that case, let's do like an in convert. It should be an in cast. Okay, not an as. No, still really not liking it. Oh, incast requires 2 args? Similar issue here. We need to int cast this. Okay, and now we're finally getting that the color is failing. Okay. So, oh, no, no, yeah, this is what's failing. Okay, so how are we going to do this part? First of all, let's actually remind ourselves of what the pixels in this thing even are. Yeah, we just want to print out this. So let's do dprint something of type any. The bitmap pixels. Debug print, and then yeah, let's compile this. Okay, so all of these, none of these are transparent technically. All of these are just white or black. So we're going to want to convert them. If we just set the, we should first of all make a decision. What do we want the text to even be? For the moment, let's keep the text white, but we want to make the background transparent. So, oh no, actually, let's just make the font parts black, and then everything else transparent. So then, for these pixels, if where's that reference again? If we see these white pixels, we want to convert these to, if the very first argument of these pixels is 255, we want to convert the next 3 to zeros and make the last one 255. Otherwise, make everything zeros. We should note this as well, since this is like a technicality. In the bitmap, the pixels, so yeah, the background pixels are black. Yeah, like the numeral pixels are white. So below we make the white pixels black, and the well, maybe, why don't we just say, so we set the numeral pixels to, we set the numeral pixels to black, And then we set the background pixels to transparent. Okay, I don't want to look like that on that side of the screen so much. It's easier if I'm looking at the middle of the screen. Or I can just literally change where I'm standing. Okay, so let's just determine what the height of what the colors of these things should be. So it might actually be easier to do this if we rewrite this RCL procedure. When we started off, I was assuming every single pixel had a transparency value of like 1. I think it's time for this to change. This would require us changing some small sections of the code, but I don't think the change would be too long. But we can see. I would just need to add 255 values to all of those ones, and that would literally be it. Okay, so why don't we change this immediately? Arraylib color is now going to specify these values. And like we did above, let's just condense this. In which case I can just say return arraylib color this. Macro time. I do really like Emacs macros. You feel the power when you're using them. I do kind of I like these better when all of them are aligned this way than this way, actually. Okay, so let's do that. And then there's no need to do this anymore. We can just simply call RLC 0, 0, 0, 0. That's fine as well. Okay, let's try compiling this. How have the areas of the screen crossed over? Oh, well, what's this? Okay, this is still failing as expected. So now we can just call, I swear it's, we can now just call this RCL function. Okay, so why don't we say constant color equals RCL of this entire thing. And now we just call the color here. No. This is like, I'm so annoyed that like this line is like massive, and then it's It's messing everything up. We'll make it smaller. 190. Expected 4 arguments, found 2. Let's just write a different function. Pixel to raylib. Pixel to raylib, which is now going to take in something of type pixel and return a color, and it's literally, this is P0, this is P1, this is P2, and P3. Hey, this kind of looks like some textures are getting drawn. They're getting drawn in a really squished way, but they're getting drawn nonetheless. The shapes look weird though. Let's fix this in the previews of what we're doing. Okay, let's draw these much larger. Let's give them a height of 200. All of these look the same, which is a bit concerning. And they also don't look like numerals. What's happening? Let's figure this out. It's almost certainly something in here. Oh, here. This should be the number of pixels we need to skip when we go down should be bitmap width, not height. Okay, great. Whole lot of ones. Why aren't we seeing 2s? And also, why aren't we seeing... Okay. We're not seeing... We haven't yet done this. We do need to do this step. But still. I'm also, okay, I was expecting to see a 2, 3, and a 4 here as well. Don't know where those are going. Let's figure that out. Let's also bump these slightly in the process. Okay. So yeah, why aren't we seeing different numerals here? And why is it this one randomly cut off some halfway? Maybe it's the loop iteration. Also, I should be iterating. I'm not doing this loop in like the optimal way. Like the optimization doesn't really matter at this, well, anyway. Like this is better for the memory layout and cache, avoiding as many cache misses. But yeah, why the same numbers? Oh, I should expect to see a numeral I in here somewhere. Given there's no numeral I expression, it just means this line here is completely independent of what numeral I is, which means we just expect to see something repeated 4 times, which is all of those ones. Okay, so yeah, this line is incorrect. This one. Okay, so what do we really want to do? We want to, we need to shift the pixels that we're reading to the left by 10 times numeral I with the appropriate cast. Oh, but since this is, you know, since we have our own, this is one of the unexpected benefits of writing our own QOI parser, because we've done our own QOI parser. Everything is in Zig, and so we don't need to do as many manual int conversions, which actually is worth it, I think. These are so tedious. Like not having to do those, pretty good. So now we can just say here, multiply this. We want to add to this 10 times the the numeral I. And we want to build it this time. Great. This is looking pretty good, except for the fact that this 4 here is getting cut off. Why? What is causing this? I mean, like, this suggests it's because we're not going like far enough, but why? Oh, could it be that I was gonna say, could it be that there's actually some kind of buffer? No, that doesn't. What is causing this? I need to like disable this clicking stuff or make it alternate. Let's do this now. Mouse click. What's the mouse click down? How do we switch the enum? Why don't we switch on game mode? And then in the case that it's the puzzle's handcrafted, we want to go to game mode equals puzzles handcrafted. Otherwise, if the game mode is it feels so long ago that we did this enum. What even is it? Okay. If it's the main menu, move it to the puzzles handcrafted. If it's actually the puzzles handcrafted, move it to the main menu. And then if it's the puzzles randomized, we'll also return the main menu. Okay, and now we're alternating between them. Okay. So now I can actually adjust the width of the screen and move it as necessary. Okay. Numeral images. It's past midnight, but I can sleep in tomorrow. And I want to fix this bug. Why? Okay, one thing we could even do that might help us figure out where this bug is actually doing this kind of stuff. This would at least help us display kind of the borders of this in case it's an offset issue. If we made the background pixels debug instead of transparent. So why don't we do this? Once we figure out what this color is, we want to say that we say the bitmap pixel color is this. We can then say that the color is actually going to equal black if the bitmap pixel color is equal to if it's equal to white, so 255. We can do this in an easier way. If the very first entry of the bitmap pixel color is equal to 255, otherwise we want to set this to debug. Can I switch? Oh, I can switch between them like this. So why don't we make this one the zigzag run? Well, what am I trying to do? Never mind. Never mind. Nirvana. If we do 192, does this syntax not work in Zig? I might just be copying this from Odin. Right, Odin lang dot org. I need to know why I'm thinking this is the right thing to do. I'm pretty sure this is why. Come on, where's the documentation here? Then if I do like tertiary, this is what we want. Come on. I mean, it's we want this operator. Yeah, here it is. Yeah, equivalent to. Wait. Okay, it's not tertiary. It's called ternary apparently. Okay. X if condition else Y. I sure. Okay, so we're currently using the Odin syntax, but I thought Zik had something similar. Ternary. Oh, it's. Yeah, is this not the same? Oh, okay, I need to wrap these in brackets. And it really should be equal something. If it succeeds, it's bug, otherwise it's debug. Okay. But this is failing for some reason. Struct color does not support indexing. Why is this the Raylib color instead of the pixel color? Oh, because we converted it. Okay. Let's just fix that. Okay, better. But still not amazing. At least we've kind of done this somewhat. Why is the 4 not displaying completely? What's up? I'm also a bit concerned that something's not exactly working with these offsets. Like, if we're drawing this 1 at 0, 0, I'm expecting it to be moved slightly to the left. At least I thought that was what this stuff here was doing, but seemingly no. So we're saying, given the 1, 2, 3, or 4 image, draw the specific pixel that we determined up here by saying at the position yi and then xi plus the offset. What's happening? Oh, What if instead of setting transparent up here, we set debug? What is that? Do we actually get squares in this? Ah, okay, this is telling us why things are failing. FYI, this is why it's always great to like have some debug color and just draw it as soon as possible. Don't know why, well, yeah, I know why I forgot to do it up here. Because it's the late night. Yes, now it's immediately clear why this is failing. So we're like adding in too much of the offset. The offset should be constant. There we go. There's the actual problem. This should be bug fixed now. There we go. Fantastic. So, okay, I'm secretly really happy. Not secretly, because I'm just saying it. Very soon we can start putting these tiles, you can start using these textures on here. This is good. This is really good. And, yeah, right, again, since we wrote our own QRI stuff, since we have just a very simple array with all of our pixels, we can easily do performant stuff on that collection instead of having to deal with the magic box of raylibs, texture, and image formats, which secretly cause malloc and other stuff in the background. So, so I guess what now? Now that this is working, let's make these transparent. And then why don't we might even be able to draw them. What's the time? Maybe we'll leave this for next time. And then for the color, just make these transparent. And then instead of debug up here, we want this to be transparent as well. But just to remember what we did, we'll mark this as debug. Okay, great. There are our bitmaps, our rendered textures. I do really want to just immediately start drawing these on it. I cannot help myself in this regard. Let's do this after we save everything. Got for textures corresponding to the numerals rendering and git clean I kind of want to delete this one. Why isn't it being deleted? Weird. Remove bitmap glyph offsets 0.png. Okay. Push that to the cloud. Okay. So let's go to the render puzzle part and now use these numeral textures to start drawing some stuff. So, in particular, particular, we're determining the background color of these based on this switch. And I think we had a to-do which was like write a separate like tile drawing function. If we do that, that would be a really easy place to choose the texture to draw. But I just want to do something quite crude at the moment, which is just put some numbers on here, then I can call it a night. I just want one number on one of these. Then we'll pick it up tomorrow. Okay, so what do we... This is a lot of drawing code. I didn't realize there was this much. Okay, so we draw some grid background. Switch these. Oh, these draw options must be dealing this stuff down here. Yeah, this is draw a procedure that draws an arbitrary tile at an arbitrary position, and use this to rewrite. Use this to rewrite the grid drawing code. Okay, there is plans to redo all of this. Draw the pixels of the bitmap by drawing a rectangle for each true value in the bitmap. Oh, this is the weird stuff that we got rid of. Okay, we can replace all of this now. So why don't we instead say... draw some of the numeral bitmaps. And this is temp, because we should replace this. So for the option drawing part, I guess we're drawing each of these 4 squares here in this part. So why don't we actually just use our numerals textures now to put textures on each of these. We need to draw them after we've drawn these solid colors. And since we're already iterating over these I, we can now say draw texture numeral textures I, and then we need to pass in the position and the height. So what's the position? Tile pose, and then the height is just the square length. That didn't compile. Zig build run. Value type of F32 ignored. What? Draw texture. Oh, I even did take the pointer to it though. And I did put in the position and I did do the height. What's happening? Value of type F32 ignored. What? Oh, again, it's... this is returning some function. That's why. Is there any good reason not to change this now and just remove this component? Okay, I hopefully don't regret doing this, but let's just get rid of it. This is like the second confusing time it's caused a compile error. Okay, so it's now a void, and now we're not returning anything like that. Okay, if we're not returning the scale W, we still need to compute it in order to figure out the top left corner of the texture so that Rayleigh can do it. But okay, yeah, we no longer need it. Okay, so for this part here, no need for that. Blank argument. Likewise for here, come on, no need for the blank argument as well. Haha, amazing. This has been quite the detour, but I will not lie. It has been a very satisfying detour. Now we actually have proper bitmap fonts rendering, and so, in particular, we can adjust the size of the screen, and these don't look blurry. Like the quality of the pixelation here is remaining constant. We're not getting some crappy blurring that does happen in several indie games. I'm not going to shame any names, but yeah. We have now, yeah. Cool, let's save all of this. Drew some of our bitmaps onto the grid. Okay. Push that to the cloud. And yeah, I'm looking forward to the next couple of streams. We can now get back to doing the game programming instead of the graphics program that was happening behind the scenes. But yeah, thanks for everyone who came onto the stream and watched it tonight, and or is watching this on YouTube. Yeah, so I'm going to be sleeping in tomorrow, but I do not have too much. I was going to say I don't have too much work to do over the weekend. That is a lie, but when I do it is way more flexible. So there will be quite a few hours streaming. That is when I'm not reading, and yeah, the book I'm currently reading is taking a while, but there should be time. See everyone later.